Okay, let's go. So moving on, let's see if we can figure out how to graph these here. So let's start with this top equation. So we got 3x plus y equals negative 3. Now I hope that you notice looking at these that these are kind of suspicious looking because the left sides are the same, but the right sides are different. So the thing is, if we're talking about where these things are going to meet, I wouldn't be surprised if this was one of those cases where they don't. But let's not worry about that. So let's do these by writing these in y equals mx plus b form. All right. So if you have 3x plus y equals negative 3, and I'm going to write it in mx plus b form, we're going to move this over to the other side then. All right, that's all you got to do. And when you move it to the other side, that 3x changes signs and becomes negative 3x minus 3. All right, so this is our top equation. So my y-intercept is negative 3. And if I have a slope of negative 3, that means I go down 3 and over 1. So that's going to kind of put me about here, but I really don't like that. So let's just reverse course. And I know that it's going to be in line with that. So let's go over to the left one and up 3, because that will give me my next point going in the opposite direction. And then we can take this and we can sort of draw this with how we think it's going to look. Get it kind of close if I don't doesn't glitch out. All right, so let's do this here. So that's what my line looks like for this. So now for my next line, I'm going to do the exact same thing, and I'm going to write it as y equals mx plus b form. So let's take my 3x plus y equals 3 and move that 3x over again. So we're going to have the exact same slope, right? Except that I have a different y-intercept now. So that kind of tells you the tail of the tape, like where this is going to go. So my y-intercept is positive 3. So I put a point right there, right? And then I'll go down 3 and over 1, because that's how you do the slope, right? Because it's negative 3 over 1. I didn't really explain that before, but that's it's kind of we're kind of assuming here that you can graph at this point, right? And so you're going to get something that looks like this. And so you can see that they have the same slope. They hit the y-intercept at different spots. So these things are parallel lines, right? These are parallel lines, which means they won't touch, right? And if they don't touch, there's no solution, right? Because the solution set is where they meet. They don't meet. So if they don't meet, there's no solution and there's nothing to worry about. It's just how it is. Okay? All right, now let's look at our next case here. So we got y equals x plus 2, and we got x minus y equals negative 2. Again, a candidate for some funny business here because the x and the y both have the same coefficients. So I'm thinking, or close to the same coefficients. So I'm thinking we're gonna have something interesting here. So let's do this one first. This is written in slope-intercept form already for us, so that's good. So my y-intercept is 2. So I'm going to go up to 2. I'm going to put a nice big juicy dot there. And then if there's no number in front of x, that means your slope is 1. All right? And another way of thinking of that is 1 over 1, right? Always write it, any whole number as a fraction over 1. So that means it goes up 1 over 1, right? And I'm always saying over to the right when we do these. So I'm going to get something that looks more or less kind of like this. That actually turned out pretty darn good. Now, this one right here, let's rewrite this so that it's in slope-intercept form. So let's move our x. So we're going to get negative y equals negative x minus 2. So far it looks kind of different. But we're going to multiply this by negative 1 because I need my y to be positive. So when I do that, my y turns positive, my x turns positive, and my 2 turns positive. And this is exactly the same as this top equation. It is the same equation. And if it's the same equation, I don't have to plot it because I know it's going to be there. So it's just a matter of interpreting your solution. So if you have the same line, that means it is an infinite number of solutions, right? There's no end to how many solutions there are. And if you guys remember what we call this is called consistent and dependent, right? And the last one we did in this video, so if we go back up here, this one is just inconsistent. I always forget to do something on all these, but there's a lot going on with these, so it's understandable. So these are kind of like our special cases that you'll see from time to time. Most of the time, for regular real life applications of systems of equations, which, believe it or not, there's quite a few, you will get a distinct solution. So they're going to meet in one place, and you're not going to have all this monkeying around to do. So hope this help is continuing to help you. And then the last video, we're just going to plot a few more of these just to get a little more practice, and so you guys can see some more situational things going on. So thanks for watching.